No, I'm kidding. There's so many of you. So, have you had lunch? Always hydrate. It's very important. And make sure if you have bottles, clean as you go so that we be more mindful of spaces. With that in mind, Amaze tries its best to be harassment-free. And if you feel unwelcome or uncomfortable, you could file an anonymous report, approach any of the volunteers, and ask for Anna or Olivia, and we'll make sure that you feel welcome and safe here. So we have a great speaker, but I'm not going to talk about him. I'm going to talk about WASP. So yesterday or the day before that, in the pink umbrellas outside, there was a wasp sleeping. And my good friend Joe told me that wasps aren't actually aggressive and they get like a really bad reputation. So all spring, they just work, have fun. But at the end of spring, they get kicked out. So they're just angry little guys. And I realize, or we realize, that it's just, corporations firing people and laying off people. So next time you see a wasp, try to think, like, is it pre-spring when they're nice little guys, or post-spring when they got laid off? So I just want to be pro-wasp, just a little. But I am anti-sunfish, because they're just little shitheads. But our next speaker is Sos Sosowski. I got it right. Woo. Yay, yes.
Sos Sosowski. I will be talking very quietly today because I was screaming at a party yesterday all night and I have very little voice left. But I would like to tell you about AI. And what I would like to tell you about is how AI actually works. Like, ask yourself this. Do you know about AI, enough about AI to actually hate it efficiently? I don't want to tell you what to think, and I do not want to repeat headlines, things that you can read about AI and probably you've seen them. I want you to be able to read these headlines in the future and be like, I knew this. Because I will tell you how AI works. We will focus on LLMs, large language models, like a chatbot that you talk to, you ask questions and they reply. And I will tell you what is not AI, what they tell you an AI is, and it's not necessarily that, what actually AI is. How an AI chatbot works, how does it output text that we can read, how do we talk to it? And how is an AI chatbot trained to work? Like, you know, the AI needs to go through training, and like I will tell you how that happens. And if we have the time, I will also bring up a little thing about what are the implications of actually using AI in your work. But first, let's begin with a fun fact. We will get a little technical here, but it will all come together. You do not need to understand a lot of numbers. So a fun fact is what is a tensor? You probably heard that name, like tensor core or tensors. So tensor, like, imagine this. This cube is a number. It can be any number, like 0 to 10. It can be also 4.5. Now, this is a vector. Vector is several numbers. They can be used to represent like a point in space, like 3 numbers, or a direction. A vector represented with an arrow, usually, graphically, and this is a matrix. A matrix is like several vectors, as you can see, and it's usually used for something called projection. Like, you get a point and you project it on the screen like a camera sees it. But actually, it's just several vectors, like several arrows here. And when you rotate these vectors, you can like use it to maybe rotate a point in space or like an object on your screen. If you made 3D games, you probably came across matrices and vectors and stuff like that. And this is a tensor, and tensor is like a more advanced kind of matrix. And if you're interested, I highly recommend, if you take pictures of these, I have QR codes for the video where UDProd tells about what are tensors and how they work. And as you can see, they don't only uniformly rotate vectors, but they can, for every direction, have a different response. And this can be used to calculate tension in construction. This is why they are called tensors. And to multiply vectors, this is a lot of math, but I would like to focus on, like, you see, there's multiplication and addition. You multiply and you add. When you do, you can multiply two matrices like here, a matrix and a vector, a tensor and a tensor, and these calculations consist of a lot of multiplication and addition. So we do it so much in computers that we have a specialized instruction for this. It's called MAD, multiply and add. And GPUs have something called tensor core. It's not a genre of music. It's a specialized hardware that will multiply. It does the math. Look, it does the math on the tensors. I recommend the tensor cores in a nutshell by NVIDIA video when they explain how the cores, the specialized hardware in the GPUs works for tensors. Now, that was a fun fact. Now I will tell you what AI is not. Now, what exactly is this AI? You've probably seen this takes a lot, like scientists. Nobody knows how AI works. Even the scientists who build AI can't tell how it works. Well, I will tell you how it works. No, it is dumb. It's just so dumb. And you might think that it's so dumb, it's genius, but it's just dumb. AI is dumb. And to take a step back, I will explain why. What can computers do? Somebody, tell me. Stop. Computers can add, subtract, divide, and multiply. They are giant calculators. Everything on this screen, the sound from my mic and back into the speakers, it becomes numbers. Everything is numbers. All computers can do is a lot of calculations. They can do this for, and all of these at the same time, and all of these at the same time, but quicker, and some cool functions like sin, and I don't mean like the sin of watching porn on your computer, but actually the nice squiggly function that you can use on your games to have nice effects. Computers are big calculators. And what is AI? AI is an array of random numbers on your computer. It's a really, really big array. And it's so big, it's there because we have excess spending, we have so much computing power that we can use that to create an array of enormous size. It's like You probably know that this is like a crypto digging rig, because AI is the new blockchain. It's just random numbers generated by a lot of GPUs. And this works because of this. Do you know the infinite monkey theorem? It says that an infinite number of monkeys with an infinite number of typewriters will write at one point, for example, Hamlet, because it's statistically possible for an infinite number. But then it goes on to say how low the chances of that happening really are if like the monkey starts typing. Like even to write the word banana, it's 1 in 15 billion chance. So you need 15 billion tries to write the word banana by a monkey on a typewriter. But then like, this might be a lot for a monkey, but a computer is not a monkey. So I was like, hey computer, can you do this loop 15 billion times? And the computer is like, yeah, it took me like 2 seconds. And like before that, the computers, like even 20 years ago, a 32-bit Pentium from 1996, would take longer because it couldn't even count to 15 billion because it's 32-bit only counts to 4 billion. And this was on this laptop on a 64-bit core, so it takes less time, but it's still a laptop. And the CPU can handle 500 bits with like AVX instructions, and a GPU with a tensor core can handle 4,000 bits at the same time. And an RTX 5090 has 690 of these cores, so it has 64 times the power and 690 times the core. So it could do the same calculation 43,000 times. That's a lot of computer power, and we can use that to put the infinite monkey theorem in practice. Now, how does AI generate text? We will take a step back and I will tell you what is a neural network. Now, this might seem a bit complicated, but it's actually not. If you are interested in details of that, scan the code and the essential main ideas of neural network by Josh Stramer of StatQuest. It's a great example, and it goes really slowly. Even if you're not good with math, you will understand what he's going on. So, these are neurons. This is a little neural network. It has an input and an output. And you put like a number here. Computers only do numbers. And then you multiply it by this called weight. You add this called bias. And then the neuron does something called activation function. Then you multiply, and then you add. And where there are more numbers, you just do more of that. So it's like, remember MAD? It's multiplication and addition. This is why tensor cores are so good for this. And basically, it can, if you can see this little faint green squiggle, so you put data, and you want to be able to predict like what is going to happen next, or maybe what is going to happen in between the data that I have. It does the statistics. It will take the data and kind of help me predict what's next. Like a bigger network can fit a more complicated squiggle, but it has also more neurons. And if it's hard to understand, I recommend this really nice TikTok by Techmora, How AI Predicts Numbers. You can see there's like very little of these neurons, and you can see how the numbers are changing. Like it takes this is the data it takes from this, and just calculates what is the probability that this image is that number. So now its probability is very high that it's 9. Now its probability that is nothing, and now it changes as it goes. And this is all AI can do. It's a probability machine. It can tell if something is something or what's gonna happen next. So like you put input data and you're like, what is the probability that this is a bird or a dog? And you can train the neural network to do that. And we were supposed to focus on LLMs, so for text. You just input the text, and you're like, what is the most probable next couple letters? And then, based on the data it has, it will generate the next couple letters. And this is basically the infinite monkey theorem of practice, because you cannot do that with like 10 neurons, but language models have billions of them. This is like a billion monkeys just kind of mashing about random things. So, but you might think, okay, but hey, the billion number things, they can probably generate a lot of words at once. So I'm just like, hey, write me Hamlet, and he's like, Hamlet. No. To write Hamlet, you're like, okay, to be, and the machine, it goes through a billion numbers, and it's like, or, and it's not sure, it's like, I think it's or, but maybe it's something else. And you're like, okay, it's or, what's next? And It's like, not. It takes like 3 seconds to generate every one of these. Like, OK, to be or not. What's next? And it's like, to. OK, to. What's next? Be. And it does not remember anything you've written before. You have to pass all the text back. It doesn't know what it did just a second ago. This is bullshit. It predicts next couple letters at a time. This is what it does. This is what happens when you talk into a chatbot. Every time, the entire text has to be fed back. Look, this is a chatbot I'm talking to on my laptop. And also, it just predicts. I have this riddle for it. What has 4 legs in the morning, 2 legs in the afternoon, and 7 legs in the evening? No bullshit, just answer, you waste of silicon. Always remember to insult your AI chatbot. And it goes, a human, because statistically this looks like the Sphinx riddle. It's supposed to be 3 legs in the evening. And then it just keeps going. And it's like, at one point, it's 7 and not 3. And it's like, it cannot go back. It doesn't have the capacity. It just generates 1 letter at a time. This is sped up. This is sped up 10 times. You can see that it's like 1 token per second. And at the end, it just has to go forward. It has no brain. It just generates the next most possible letter. Like, you just pass in the text, and it tells you what is the next possible letter. This is how it talks to you. There's no talking. There's no memory. I mean, even 50-year-old computers had some memory, and this doesn't. Just putting the text through the number ringer to find the most probable next word or a couple letters is like weather forecast for text, but dumb. And it is just extra text prediction with some extra tricks. So, like, for example, they recently introduced the thinking phase. They call it the thinking phase. So what it does, it generates implicit text that normally it wouldn't show to you. And it only does this so that because you have to feed back the entire text back to it, so it can generate maybe a better answer later because it has some context that it generated for itself. It just... And of course, it has a lot of limitations. So one limitation that's very important is the length. It has, like, you know, the inputs. There's a number of inputs. You cannot go over that. So this model that I'm using here has, it's 30,000 tokens. Tokens like 2 or 3 letters. The most complicated ones have like 100,000, over 100,000. But still, if you think you can like fit a PDF and be like, hey, summarize this, it does not. Sometimes it has to do it in parts, and it's like, it doesn't really do summarization. That's not something it can do. It can only predict what is statistically in internet and the data set that it has, what should happen, what would be said after I said summarize this. This is the only thing it can do. It has no memory. It doesn't remember. It only remembers what's in the prompt, and it takes up space. And if you have a system prompt telling you that you are a helpful assistant helping me to buy a plane ticket, this also takes time in the prompt. And some of the chatbots have like context about you that is summarized by the chatbox from. It's just a probability machine. It just has this, and its job is to predict the most probable next couple letters. And it can be easily fooled. Like this one, I asked the same question and said carrot, but this one is really dumb. Like this one is more parameters, so it actually got it kind of right. And the most important thing, it must be able to err, must be able to be wrong, at least a bit. Like, I mean, text is binary data, right? But it uses floating point because the output data is the probability of the next token appearing. But then, then this is too much for the GPUs, so they quantize this data. They take the 16-bit floating point and squeeze it into 4 bits. 4 bits is like 16 different values. It just doesn't make sense. Why are they doing this? It's not meant to do this. If you want to try this at home, you can download something called LM Studio and just try, and you will see how it works and how slowly it works on your computer, how much electricity it uses just to predict 2 next letters. But now, okay, but how does it know all this? No, it doesn't know anything. This is how you train AI. So we have the neural network, of course, is bigger. You put some random numbers here. And then you like put some input data here, and then you're okay, generate output. And it's like just generates random stuff because it's just random numbers. and then, okay, it's wrong. And I will put some other random numbers here. And this is also where the training data comes in. Like a training data is a lot of text, and you would put actual text from the internet or a book here, and be like, okay, what's next? What should be next in actual text? It is trained to reproduce the training data verbatim. It is not trained to come up with creative stuff. It is just trained to copy. And it's like, when you do this, when you just change these numbers 6 billion times, and I'm not kidding, this is what happens. You have a lot of random numbers that can somehow generate text because you were able to invest a lot of time into changing the random numbers. And some people will go, no, it's not random. There is backpropagation and gradient descent, and we can calculate. This is also from the Josh Strammer. I recommend that, backpropagation. They use backpropagation to guess more directly, like we can predict which weights to change, which numbers to change, and how much. And like, okay. You just put less random numbers here. I mean, that's where AI is. A giant array of numbers is an infinite fucking Sudoku. And scientists do not know how it works. They do not care because they have so many GPUs. If it doesn't work, they just throw more at it. Like, if you knew what numbers to put there, like with backpropagation, why do you need to repeat that 6 billion times? It's just random numbers. There is no magic. Like, imagine you go and see a magic trick, and there's this guy, and he like, okay, I'm going to try and do this 6 billion times. You wait, and the probability that I will pull a rabbit out of this hat is really high. This is no magic. AI will never think. AI will never be sentient. It will never write or answer. The only thing it can do is predict what are the most statistically probable next couple letters. It's not even meant to do this. It's like a weather prediction machine for the squiggles. Text is not squiggles. The fact that it generates text only happens because they threw excess amount of compute power on it. And now they want to push it further. It's just not going to happen. Just a giant array of random numbers that is brute forced into this. And you cannot do this at home. It's not possible. Like you think, I can train AI at a computer. Training AI model from scratch costs millions of dollars. Somebody tells you that they trained their own model. Usually what they do is they take existing model and up-train it. And for example, I tried to train AI, like it was 2020, and I was out of the office working from home and a computer in my office. I was like, okay, how about I train AI to generate images of my game using the footage of my game from scratch. And I did that, and after a full month of running my GTX 1080 at 100%, with nothing. I don't even have anything to show. It was just a soup. That was like 128 by 128 resolution. Like, imagine how much compute power do you need to actually do these like 6 billion calculations and do that. AI is reserved only for giant corporations. Training AI costs grows exponentially. That's probably something you read or heard recently, because the bigger network, the more random numbers you have to randomly change to other random numbers. The amount of compute put into this is insane. It's just brute forced. It's blockchain all over again, but now it can write you a limerick now. And let's try another 6 billion times and see what happens. Do not use AI. It sucks. Fuck AI. I'm not done. Thank you. I am not done. I told you if you have time. Do you have time? Do you have like 3 minutes? 8, all right. So I will tell you about like if you watched all this and you're like, I don't get it, or like, okay, but it still generates stuff, like the stuff that it outputs, I want to use that, like why shouldn't I? I want to tell you something about the implications. Like, this is my perspective. It's not just how AI works. What are the implications of using AI? Now, first is the copyright. As I told you, it's trained on the training set, and it's trained to reproduce that. Like, for example, if you generate code, and it's trained on a GPL license code. GPL is the license that makes you open source your code. And if it's trained, it will be able to produce that. And if it produces that and put you in your code, or maybe a patented code that can be open source, but you need to pay patent fees, and it might be able to do that, and you will put that in your code unknowingly, and you will be subject to some kind of license or patent fees. I know there's like license for the code that the things generate, but you need to remember that the code it generates, if it's the same as the other code, somebody can be like, hey, dude, come on. So like, yeah, the same goes for images. Like if you go to an image thing and you're like, okay, there's no copyright for things, but you tell it to generate copyrighted stuff, you cannot use that. That's obvious, right? And the second one, I think even more important, is quality implications. Imagine this. I open up like a web page of your game, and the first thing I see is an AI, even like a capsule image, or like, you know, a box art. It's not even in the game. But what do I think? I think, hey, this is AI. If this is AI, is this the only AI thing in the game? Maybe like, okay, maybe the person cannot draw, but maybe they cannot write as well. Like, how can I know now, after seeing this AI one thing, that not more images was made by AI? And how do I know that the text wasn't written by AI? How do I know you're okay with using it for an image, so not what for text? This is a boundary that when you cross, there is no going back. Remember about that. If text, then what not code? Was code written by AI? I mean, you're okay with AI. Maybe you're a bad artist, maybe you're a bad coder, maybe you're a bad writer, maybe you're just using all of this. And was anything made by a human? How do I know that any human effort was put into this? And most importantly, if no human put an effort into creating something, that when I, a living human, should spend any amount of time to experience that. Thank you. Thank you. I hope it wasn't too fast. It was like 80 slides and 20 minutes. And I was just told we have time for questions.
Yeah, we have 5 minutes. Does anybody have a question?
Yes.
Can you?
Oh, no.
Are you okay?
Oh, it's okay.
Are you right? Are you right? Oh my God. Yes.
Not really a question, but a request. My company is contemplating using AI art right now, and we're having heavy discussions about it. Could you publish the slides somewhere? Because there's really good talking points.
I think this will be online. Will it be? Yeah. You can just show them this.
Thanks a lot.
Hey. Anyone else? Yes.
Oh, I'm scared of going.
In the back.
Is it here? Yeah. Can you talk about, because last year you talked about dependence on engine, can you talk about dependence on AI when you start to use it?
I mean, I don't use it.
Well, someone theoretically using it becoming dependent on it, if you make game with it, for instance.
I really can't tell. It's not something I relate to, right? I don't use it. I'm interested in the concept, like as you've seen, you know, I kind of interested, but like the big generative things, they don't interest me. I'm sorry.
Okay, all right.
Maybe one more?
Last one.
So in the past, when photographers were using film, they used to use Polaroids for like a quick prototype. And you can't control the developing process, and it's like also kind of random.
I know the answer.
Okay.
You're like, hey, can I use the AI for prototyping? Is that what you want to ask? Yeah, how about you draw that in MS Paint? Like, what's the deal? And then, like, when I look at a game, like, the last point that I made, like, if I see something made in an AI, I would be like, oh my God, is this like, I don't want to touch this. Like, maybe no human made it at all. But if I see something drawn in MS Paint, I'm like, yeah. So yeah, I use MS Paint. And I think this tells something, right? Like, people will expect more quality for something they see an MS Paint image than the AI-generated image. Like, this says something about what kind of weight it has, I think. Use MS Paint. It's great.
We have 2 more minutes because you talk so fast. Do you want one more?
One more question. Yes. This person in front. Catch it, catch it. Woo! That's 3 points.
Incredible. Incredible throw. We are all here because we are part of the sort of dev community. How do we relate this to a market that might not be bothered by seeing an AI image?
So what I think is like the sentiment, that's my idea, that the sentiment behind correlating AI with low quality, like AI-generated content with low quality, will persist enough for the market to be like, we don't want this, because then everybody, like every time you have a product with visible AI things and product without, people will rather pick the thing without AI, and this will kind of phase out. That's my idea, that it will phase out the AI, and you will always be able to tell. You will always be able to tell. Hopefully. I catch it now? Oh my God! Woo! Thank you! Okay, if anybody is shy, I'm going to be around, just you can go and ask me questions. Thank you again for coming, and stay for the Hyper Talks.
It was good. Sorry. Hello. Hello. Hi. Hello. Who here is first time at the maze? First time? Okay. Welcome. HyperTalks is, I think, is an institution at the maze and something that is you have to experience at least once, if not every year. With that in mind, Amaze really does try to make the space harassment-free and safe. So I think they have to include now that people shouldn't throw phones. It's really bad. Who does that, right? Somebody should report that person to people. But let's try to settle down fast. To people who are leaving, please leave so that the people who want to come in can come in. Find your places while our wonderful hosts of HyperTalks are setting up. And also, I just want to say for people who have been